Hi everyone, Sonu here. Welcome to my channel. Today topic is software architecture pattern. I'll recommend you please bookmark this video because in this video I'm going to share some of the practical example and pros and cons. I will share just because of my experience in a startup, I got opportunity to work on all the architecture pattern. So I know what is the pros and cons of all the architecture. And and I will also tell you no architecture is perfect in your business. You need to take a call for which software you need this architecture or other architecture. It depends on many factors like cost can be one factor, scale can be another factor, maintenance can be another factor. So according to that, you take a decision. It's not like uh, first one is right, second one is not right. There is no ideal architecture, I would say. Okay. In practical world, all the software is built on top of multiple software architecture pattern. It's not like one architecture is going to solve all your use case. Okay, let's start with this video. Before we start, I just want to define these things, why you should consider subscribing my channel. In this video, I have around 12 plus year of experience in a healthcare startup. I mostly worked as a initial developer in a company. Mm, Just because of this, I know how to build a tech platform with two or three developer and now how to maintain your platform or scale your platform for a larger group. So I have gone through this journey in my previous three startup. That's why, and I got also opportunity to code in all this area. Like I coded in backend, I coded in app development, I have done DevOps things, machine learning, and prompt engineering. So this channel is going to help you with the practical tips, I would say, and this will help in you in your career. Okay, what is the difficult in software developer? Building a building a feature or maintaining a feature. If you understand this point, you, I mean, if you speak with any senior tech developer, they will tell you maintaining a software is very difficult. And of course, if you have not built your software with the proper architecture or design pattern, in longer term, this is going to be a painful for you. So building with considering all the architecture, database design is very important. Otherwise, this is going to be a very painful when you maintain this platform or you want to add multiple feature or you want to adjust multiple new business requirement. That time you will find very difficult. And because of startup, I mostly share example of a startup because of my experience. Okay. So in a startup, because sometimes you don't have clarity of what this where this feature is going to scale, right? And also you don't know what other use case will come in this feature. So then you are building something, and over the period you are keep adding something in a uh, something in that tools, right? And it's because it's a long journey. This is not uh, you are just building for a particular client and you are delivering your project and your job is done, right? This is not how startup work, because if you have done anything wrong, you need to fix it. Okay, maybe you need to fix now or you need to fix after 6 months, but ultimately you have to uh, you have to solve your problem, right? I mean, ultimately no other developer will come and solve your problem. Like ultimately you are going to face your code again in a longer term. Did I know architecture pattern in detail when I started my career? I think I will say no. Most of the developer not aware with design pattern when they start their journey, because when you start your career, you started contributing to some of the existing code base, right? So that time you broadly know about the architecture pattern, but you don't know details of architecture pattern. So I would say this is something which you learn over the period. Okay. Why do you need architecture pattern? This question is like, for example, if you are building a house, you can build house without any architect, but architect is required if you are building a complex house. Maybe you are building an apartment and you want to add multiple floor there, then you need an architect because architect have a standard practice. They have implemented that practice in multiple apartments, so they know what is the pros and cons of that architecture. Similarly, in software development, when you go through any design pattern is already tested in multiple business use case. Maybe some design pattern is well tested in fintech, some are well tested in healthcare, few are well tested in other business use case. So when you go with the architecture pattern, you know this is already tested and tried by so and so company, right? So you can also try it. And because of design pattern is defined, they have their own pros and cons, their guidelines are there. So it will be easy for your new developer to grasp your current code base. That's why architecture pattern, design pattern is very important for you. Definition of architecture pattern. What is an architecture pattern? Okay. So first, this is a solution for common problem because there is some sort of uh, principle which is attached to all the architecture pattern. Every architecture pattern and their own style of development, own style of uh, they have their own limitation. Okay, limitation, pros and cons. So based on that, you just take it a call. Okay. Second is there is a standard component and interaction practice which is defined for all the architecture pattern. And this architecture pattern, of course, well tested with multiple business use case. Okay. Will this video cover design pattern or architecture design pattern? So I just want to make this clear. This video is only cover architecture design pattern. That means architecture design pattern is very broad of any architecture. So design pattern is one component. Okay, one component like you are creating a singleton class. So those kind of things is a small design pattern. Okay, when you talk about architecture design pattern, you are talking about how your multiple component, your multiple business things will work together, how they will communicate with each other, how they will be deployed, maintained, developed, those kind of things. Okay, so let's go with this video. We will, I'm just repeating again, we will only talk about architecture design pattern. This is very broad of design pattern. Okay. So I have divided this architecture design pattern in three categories: application landscape, application structure, and user interface. In this video, I will cover application landscape in detail. In next coming two video, I will cover application architecture and user interface in very detail. Okay. So let's start with application landscape. Okay, so in application landscape, there are very popular arc, application uh, design pattern are there. So let's go with monolithic. So uh, in monolithic by nature, all your backend, frontend, and database is deployed and managed in one place. I can give you one example of this is like WordPress website. If you see the WordPress website, in most of the case, their backend, front end, and database is deployed on one virtual machine. That means they are very tightly coupled with each other. But still, if you see the software industry, you will find lots of website is developed in WordPress. So it's not like monolithic is not used by company. It depends on what is your use case. So let's say if I have to build a one static website, instead of going to React, creating a backend, or doing some sort of other things, I will simply go with the WordPress. I'll create one website and deploy it. If I don't have any other major complex things required in future. Okay. Nowadays there are lots of monolithic architecture is available. Okay. And they are you can use on larger scale as well. Okay. So it's totally depends on what is your use case. Okay. Because of there are advantages are like, because all things are one place, so you can easily understand, you can deploy, and it's very ideal for small limited scope project. Because so let's say I just give you example, you have one WordPress website, you can go with the this architecture, there is no harm, right? Disadvantage is because all three component is very tightly coupled. So if you are making change in any place, like let's say if you are making change in database, this is going to impact your front end. This is going to impact your back end, right? And because of this, this is tight coupled. It can lead to complex code, because you are keep sometime in digitals you are keep getting a new requirement, right? And if you keep adding a code there, this is going to be a very complex, and it will be very hard for you to manage. Okay. And it's not, of course, it's not suitable for all use case, right? I already told you, in some case it's not you can't go with monolithic, right? Let's talk about NTR. In NTR, most one of the most popular architecture in NTR is three-tier architecture, where backend, frontend, and database is deployed, developed, and managed in three different places. So, for example, simple example, let's say you have a Android application. Okay, your Android or iOS application have a different code base. You have deployed, you have although sometimes you have a different team, right? So they are doing app development, they are managing it separately, they are also deploying on App Store, right? Your backend in other uh, site is deployed on your cloud, right? Your database is maybe SQL, managed SQL, or self-hosted SQL, but that is also deployed and managed in a different place, right? So this is called N-tier architecture, where you have three different teams, which is managing deployment, release, maintaining. Because of there are three places where that's how you manage your platform. By nature, this is scalable, right? Because all three are in a different place and you have an independent team to manage it. So you can speed up your development, you can deploy it separately, you can scale it also, right? Disadvantage, because there are tiers, right? It can ripple. I mean, one things can impact others. Potential, and it can adds multiple layers, right? One layer, if you make any change in one layer, it is going to impact another layer, right? So that's how there are pro cons disadvantage of this architecture. I already give you example like app development, React JS website development. Your front end is different, your back end is different, and your even database is different, right? Let's go to another architecture, and this is a very popular architecture, because this from here microservice architecture started. So it's a service oriented. Okay, let's talk about service oriented architecture. Service oriented architecture, where project is defined divided into multiple service. So for example, you have a subscription, you have a different service for managing a subscription, you have a registration, you have a different service to manage. But the limitation is there is one ESB class or common class which interact with your service layer. So there is one common place So for example, I am giving a simple example. Let's say in back front end, you are calling one API. Let's say register my, you are calling buy subscription. Okay. So this request will go to your ESB. Your ESB will call multiple service. So for example, this will call your email service. This will call your SMS service. This will call your SMS service, and then this will give you a result. So limitation here is you have very complex ESB here, because one ESB layer is uh, separating your front end from back end. Of course, back end have multiple service. So by nature, it's kind of microservice. I'll tell you later why this is different from microservice. But here there are multiple service. But still you have one ESB layer which is interacting with all the services. There is no way service can interact with each other. Okay. So service can interact with each other by using this ESB layer. It's a common class. Okay. Example is I can give you in same app development platform. I can give you example of service oriented architecture. So let's assume you have a app. In app, you are calling to one interface in your backend. That interface in interacting with multiple service. Okay. And your service is not interact with each other directly. Okay. So they can only go through this common enterprise service bus. Okay. What is the advantage? Because of multiple service are independent. So service are loosely coupled. One team can work on your register service, one team can work on your subscription service, one team can work on your, let's say, report service. Okay. So you can assign multiple developer, they can work on service. Of course, they will interact with one common bus. Okay. So I mean, this is a initial stage of microservice. Okay. What is a disadvantage here? This disadvantage is because of there is a one common enterprise service bus that reduce agile nature of your backend development. And because there are multiple service deployed, there will be additional cost. Okay. So this will also add a cost to your platform. Next thing is microservice. Microservice architecture is next step of your service oriented architecture. So if you understand this service oriented architecture is like there is one common service bus, enterprise service bus, that is a communication channel within your all the service. Now, in case of microservice, your microservice is independent to interact with each other. So there will be no common. In simple word, let's say your application, in this example, your app, if you have to register your user, you will directly call register microservice. You will not call one common ESB class. So request will go to register directly. If you are doing anything for a subscription, so your request will directly go to subscription, and all microservices are deployed independently. They have their own way, own database, so they can interact with their database. They can give you a result. If they this microservice require any kind of communication with another microservice, so they can connect with each other. Usually there are two way to connect with each other, like they can call a REST API or proxy call, and also they can do some sort of queue communication. So let's say on after subscription, you need to trigger an email. You do not want to do in a main thread. So what you can do is you can set up one common RabbitMQ or another queue. By using that queue, exchange uh, you can exchange information from one microservice to another microservice. From one microservice, you are broadcasting the message through queue. Another microservice will be a receiver which will receive and take action there. So if you understand this microservice correctly, like this, here all your service is independent. They are free to connect with each other. They You can scale particular microservice. Let's say you are getting lots of traffic in particular microservice service, so you can scale more, right? So here you can optimize your software architecture easily. You can scale it very easily. Example is very same. I already told you the example. Advantage. Let's talk about advantage. Advantage is it's very loosely coupled because everything is independent now. It's very agile by nature. You can assign developer. You can assign a developer for particular microservice. He will be able to, he or she will be able to manage that microservice separately, right? And it's very reliable. Okay. And because by microservice by nature interacting with each other, so it's very friendly in terms of uh, bug fixes, because you usually know where is the bugs. And in microservice most of the time you have automated architecture, like you have a CI/CD pipeline, Docker for your deployment, you have sort of cloud function or another place which will read your log and give you some sort of alarm if there is any bugs. And all microservice sometime call each other, so you know where is a failure. So just because of this, this is also a costly micro architecture. But advantage is this is very scalable. Any point of time you can scale. Okay. What is a disadvantage? And disadvantage, I am telling you because I in my last two company I'm using this, so I know what is the painful things in a microservice. One thing is like in some of the case, you have one database behind your microservice, and now because and this is by the way this is not a wrong things. Although microservice is recommending to have a separate database, but it's not feasible every time. Like this is going to increase your cost. There will be some, let's say there is one report microservice where then you have to connect with multiple database to get the data. And sometimes you do not want to add that level of complexity in the beginning, right? So there is no harm to go with one database. Only the thing is you need to write proper boundary, proper discipline for all the microservice. What is which things should be keep in this microservice, which should not, that should be very clear. And it you need to educate your team. That is also one of the important things, because let's say you know the boundary and all, most of the time this kind of things in senior developer mind, you are not communicating with your junior. If you are not communicating, they will do the mistake, and then you have to raise those kind of things during code review. So proper kind of education is required here. You need to explain why you should not keep this here. What is the objective of this microservice? So for every microservice, there should be an objective. Which table this will hold? Because in some of the microservice database is same. So I usually recommend them to define a database of microservice. So every microservice should map to, let's say, 5 database. For example, you have a subscription microservice that should map to all the subscription database, related database. That means no other microservice will do any kind of write, read to that database. If you need any kind of information related to subscription, you need to call subscription microservice API. You can exchange through API. You can't directly because you have a same database, so you can't directly write the fetch query there. So those kind of discipline is tough to manage, and I would say that's why this is a complex architecture as well. But if you have defined your microservice well, this is one of the best architecture I have ever seen. because once this is running up and running, it's it's very a relaxing architecture, because you know your things are working, you are getting a proper alarm, your code, you are just pushing your code is deployed, everything is like look like you are sleeping or your code is working. It's not ideally, it's not work like that, but still you have a good architecture. You know, let's say for particular microservice, you are going to get lots of traffic. You can easily scale, and because of Kubernetes or any kind of Kubernetes kind of deployment, it's very easy, right? You can apply kind of auto scaling there. That's why I recommend microservice for a company if you are building any startup for, and of course, startup by nature. One advantage I will tell you for microservice is like sometime in a startup you are building feature, okay, and after a 6 month or one year you realize this feature is not relevant. So if you go with a monolithic architecture, you will write in same code base. It's very hard to deprecate your code, right? In microservice, because you know this microservice is not required, you can simply discard. You can reduce cost that same time, right? Of course, because of multiple deployment, multiple automation things, this is bit costly. But of course, you think, but in a maintenance time, it's very easy to code. If you have any bugs in subscription, you can ask developer, they will see the limited code, they will make a change and they will deploy it. So in that sense, I will say this is the best architecture if you talk about any production things. Okay. But other architecture is also important in some of the case. In end of this video, I'll give you some of the practical tips which will help you to take a decision. Okay. Let's talk about serverless architecture. Most of the time, serverless architecture developer use for some of the small things related to backend. Let's say you need to deploy your machine learning pickles file. You can use this because you need to write less code, you need more scalability there, and because of cloud function, it's very scalable. Okay, you can easily scale. It will optimize your cost as well, because this is most of the time this is self-managed by cloud. So in some of the case, I am using for managing a log, reading the log, and creating a proper alarm. So those in some of the case, I mean, I will recommend you to go with the serverless, but I will not recommend for complete platform because there are lots of limitation in cloud serverless architecture. So, and it's very, in that sense, it's very tough to manage. Okay. What is the disadvantage? Cold start. I mean, you- when you deploy anything in cloud function, this take time. Okay. Limitation is there. Like uh, most of the time, like GCP and Google will give you some sort of uh, Python version or Node version that only you need to use. You can't use any other version that is not available in that vendor. So there will be some sort of limitation there. Of course, other things like state management, those things. Next architecture is peer-to-peer architecture. This is very popular in terms of multiplayer games. So in this architecture, there are multiple network. I mean, you have a different application, and they connect with each other directly. There is no central server or anything which will connect with one network to another network. So all network will discover whenever there is any request, they will discover the path and then they will directly connect with each other. So in some of the case, there is one central kind of server which detect if there is any new request. For example, in multiplayer game, when new uh, player joins the game, then this central server will just uh, get this new request, and after that, just initiate the process. After that, the one server will connect with another service directly. So just because of this is a multiple network, right? And all can connect with each other. In this architecture, uh, because there is no as such any central uh, s- network to manage communication. So there is a security thread involved with this architecture because you can't centralize any kind of security principle here. And just because this, whenever there is new request, server will connect with each other. So it's very easy to scale, and also according to uses, you can expand your server. So this is also a cost effective in some of the case. Uh, Example of this architecture is like multiplayer games by torrent, where you are sharing the file. Uh, so when you are sharing a file, you are connecting with one to another, and there is no any other party which kind of moderate this process. So you are directly connecting with one to another, and you are just downloading the file. Advantage is like scaling is easy, no constant connection, so that between one network to another, so that reduce your cost. Security is a concern in this architecture. Let's move to, okay. So now time to practical tips. I told you I'll share you some of the practical tips. So according after working with many company, I realized there is no as such one good architecture. So depends on your business use case. You need to pick multiple architecture, and in any company, in one point of time, there are multiple architecture is running. So it's depend case to case, right? For example, if I have to deploy one website and that is just for sharing the information, I'll go with the WordPress. This will be a monolithic because there is no as such coming change in that website, right? So I'll simply keep this. But let's say if there is an API where you need a constant development, you need constant new module according to your business use case, then you need a kind of microservice there. There are some use case where you actually need a processing, or you need to deploy ML. In that case, maybe you can go with the cloud function. So those kind of things in, you can do. Practically, I mean, there is no one microservice that will fit your business. And of course, when you are deciding architecture, you need to also very sensitive about your cost, because it's in every case you can't introduce microservice because this is going to cost. Okay. Now what is next? So in next video, I'll create a video for application structure labor design pattern, architecture design pattern, and user interface related architecture design pattern. Thank you. Have a nice weekend. Uh, Please subscribe to this channel for video like this. I'll keep creating video week on a weekly basis. I'll create one video. Thank you.